The final example I want to explore is the script I used to generate the trees placed along a windy road example I showed right at the beginning of the presentation. In addition to curve interpolation, it demonstrates ray-to-surface intersection techniques, which can be very powerful. So here's the scene again. It's a hilly ground mesh over which winds a road. The road is another mesh that follows a spline curve, this green line here, that itself has been deformed to follow the ground surface. There's also a single master tree object that will be instanced along the road. Here's the script again. It's been reformatted slightly and we've added comments to make it clearer. So let's run it first. I'll get out of the way and Control E to run, and here come the trees. You can see they're placed randomly within bounding strips along each side of the road, and they vary in scale. The code to do this is basically a loop over the number of trees requested. For each tree, it picks a random offset along the curve and then computes a random perpendicular offset at that spot, and then fires a ray down through that spot to find where it intersects the ground mesh and sticks a tree there. It needs to perform this extra step of finding the exact spot on the ground mesh because side slopes might make it higher or lower than the road, and further, the curve doesn't exactly fit the ground, as you can see. So let's look at the code a little bit more. So here's the loop, looping over the number of trees. And here we get a random interpolation parameter between 0 and 1. And then use the length interp and length tangent curve functions to find the position coordinate and tangent vector at that fraction along the curve. Then a random offset between 5 and 18 is picked and made positive for the first half of the trees and negative for the second half by multiplying it here by either +1 or -1 based on the result of this if expression. This will put the first half of the trees on one side of the road because it's a positive offset, and the second half of the trees on the other side of the road because it's a negative offset. The next line uses a vector cross product function to construct a unit vector perpendicular to the plane made by the curve tangent and the world z-axis so that it is pointing directly out to the side of the road, and then scales it by the random offset that we just generated. Then I add this offset to the position vector along the road so that we get a point in space level with the road and out to the side. Now I want to find the point on the ground surface exactly under or above this offset point, and I can do that with the intersect ray function. This takes a surface and a ray through space and gives me the point on the surface that the ray hits. Now, a ray is another kind of 3D value in MaxScript, in addition to vectors and quaternions and so on. It consists of a starting point in space and a direction vector telling which way the ray is pointing. It has a start but no end, shooting off to infinity along its direction vector. So we need to construct a ray that starts way above the surface and points perpendicularly down through the curve offset position. The ray this is done here in this ray constructor. The ray constructor takes two parameters, a starting position, whose x and y I get from the curve offset vector, and whose z I want to make way above the curve, so I set it here at 1000. And it takes a direction vector here of -z, so that it's pointing directly down through the surface. So now I can do the ray intersection function to get the tree position. Now here's the function call right here. Now it actually returns not a point but another ray as its result, which starts at the point of intersection on the surface and whose direction vector is the surface normal at that point. Now I don't need the normal for this job, so I dig out the ray's start position via the .pos property operator here. The intersect ray function is very versatile. You can use it to place objects on surfaces, as we are doing here, or perhaps to resample a surface on a fixed grid for game engine export, or to find interpolated normals at arbitrary points on the surface, say to align other objects to the surface. And lastly here, I generate a random scaling factor in the range 0.2 to 1.1, which will be used to generate trees of varying scales. Now I have the values I need to plant the tree, which is done with this instance function. It's like the copy function, so it takes all of the geometry constructor keyword parameters like pos and scale and name, but generates an instance clone of the given object. Normally, when a script runs, MaxScript lets it run to completion before updating the viewports, but since this loop can take some time, I've added some code here to periodically update the viewports so we can see it progressing using the reDrawViews built-in function. The condition uses the mathMod function to detect when the loop variable is divisible by 10, so the viewport is updated for each batch of 10 trees planted.